Hello everyone, welcome to Chemizon Complete Chemistry. So in today's video, we are going to see some of the questions of TIFR 23 chemistry paper. Okay, 2023 chemistry papers. So this is the part 3 of the video solution. So we had seen some of the questions in the part 1 and part 2. You can see that if you have not watched them. So these are the questions that we are going to discuss in this video. So first is you have to predict the order of basicity. Now, how do you determine the basicity? What is given to us is the conjugate base. Okay, what is given to us is the conjugate base. So what we have to do is, we know acidity is what? Acidity is inversely proportional to that of basicity. Okay, so what you can do is take all the 4 anions, CH4, CH3 minus, take all the 4 anions, and what you can do, you can add H plus ion and then you can compare their stability, their acidic character. Okay, what you have to do is you have to add H plus ion. So you will get here, you will get methane. Here if you add H plus ion, it will be R C triple bond CH alkyne. Here if you add H plus ion, you will get water. And in NH3, okay, this has lone pair, this can pick up H plus ion, you will get ammonium ion. Okay, now which is going to be the strongest acid? Okay, which is going to be the strongest acid? So if you think water is going to be strongest acid because it is more electronegative, the answer is wrong. Why? Because positive charge on an electronegative atom is never stable. So the most strongest acid will be ammonium ion, because this nitrogen wants its lone pair back. When it can get its lone pair back? When one of the H plus ion is lost. So NH4 plus is going to be, this I am writing the order of acidity. Okay, NH4 plus will be the strongest acid. Okay, after this, then what you can do is, then you can compare the stability of this conjugate base. Okay, so if I remove H plus ion from water, negative charge is on oxygen atom. Here the negative charge is on carbon, and here again it is on the carbon atom. Now we know oxygen is more electronegative than carbon, so negative charge on more electronegative oxygen will be more stable. So this will be, water is the next acidic compound, and then between CH4 and alkyne, here hybridization is sp3, here hybridization is sp. If I want to calculate percentage S character, how do I calculate percentage S character? It is number of S orbitals divided by total orbitals into 100. Now why I am calculating percentage S character? Because the acidity is directly proportional to percentage S character. So in sp3 there is 1 S orbital, total there are 4, so total there is 25% S character. In sp, if I want to calculate 1 S orbital, total 2 orbitals into 100, that is 50% S character. So here the S character is more, so this is more electronegative. Okay, it is more electronegative, that means acidic character is more. Negative charge will be more stable in alkyne as compared to alkanes. Okay, so the next acidic compound will be alkyne, and last will be methane. This is the acidic character. Is acidity asked in the question? No. What is asked is the basicity. So here I am writing in the left, basicity order will be opposite. You reverse the order. So it will be CH3 minus is strongest base, then this is the strongest base, then OH minus, and then will be ammonia. This is the correct order, that is, which is correct answer? Option A that they have marked in, they have highlighted the correct answer. Okay, so the correct answer is what? Option A for this question. Next, this is a question from mass spectrometry. We had seen a lot of questions in mass spectrometry. This is a very simple one. A low resolution mass spectrum of 2-chlorohexane. What is 2-chlorohexane? 1, 2, 3, 4, 5, 6. Okay, 2-chlorohexane exhibits a group of signals. So some M by Z values are given to us: 120, 121, 122 and 123. Okay, what isotopes are responsible for the signal at m by z is equal to 122? So first of all, what we can do is we can calculate the molecular ion. Why? So that we can come to know what is the m plus value and exactly what they are asking. So here, how many carbons are present? 6 carbons. Okay, this is CH3, this is CH, CH2, CH2, CH2 and CH3. So total how many carbons are present? 1, 2, 3, 4, 5, 6 carbons. See 6. How many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 1 Cl. So we can calculate the M plus ion. How do you calculate M plus ion? By calculating the molecular mass. So 12 atomic mass of carbon into 6 plus there are 13 hydrogen, 13 into 1 plus 1 into this is 35.5. So add this 12 6 are 72 plus 13 plus 35.5. So this will be 72, 13 and 35.5. Okay, 5 0, 1, 7, 8, 9, 10, 11, 12, 120. So you can say approx m by z value is what? 120. So m plus value is what? 120. So what they are asking us to calculate is m plus value of m plus 2. Right? M plus 2, that is 122. Now how can we calculate this? 120, the normal naturally occurring isotopes are, for carbon it is 12, for chlorine it is 35, and for hydrogen it is 1. So this is m plus value. Okay, molecular ion, in molecular ion these isotopes will be present. We have to calculate m plus 2. M plus 2 means the overall mass should increase by 2 units. So we have to check where the mass is increasing by 2 units. So let us write down all the options. 12 carbon, 35 Cl, 2 hydrogen. Sorry, 12 carbon, 35 Cl, 1 hydrogen. So first option is given. This is the first option. This is m plus. This is not m plus 2. This will correspond to 120. So this is incorrect. B option, 12 carbon, 35 Cl and only hydrogen is increased by 1. So this is what? This is m plus 1 value, 121. So this is also incorrect. C value, 12 carbon, 37 Cl and 1 hydrogen. So here you can see the mass of Cl is increased by 2 units. So this is what? This is m plus 2, or mass of this fragments here it will be 122. Now last option, 13 carbon, 37 Cl and 1H. So here atomic mass of carbon is also increased, chlorine is also increased from 35 to 37. So this is m plus 3. This will be 123. Okay, we want the m by z value should be 122. So that is why the correct answer is option C. Okay, the only thing that you have to do is you have to check what is this value, m plus 2, m plus 1 or m plus 3. For that we first calculated m plus value. Okay, molecular ion value. Okay, another question from mass spectrometry. Okay, here what is given? M plus 2 and m plus 4. So this is based on what? This is based on the intensity ratio. So m plus 2, m plus 4 ratio is given. It is 1 is to, is 9 is to 6 is to 1. 9 is to 6 is to 1. The question is, it is which of the following compound will have this ratio? So first compound is 1,3-dichlorobenzene. 1,3-dichlorobenzene. This is 1,3-dichlorobenzene. 1, 2, 3, 4, 5, 6. Okay, chlorine at first and third position. B, 1,4-dibromobenzene. 1,4-dibromobenzene. C is 1,4-dichlorobenzene. 1,4-dichloro, and last is 1,1-difluoroethylene. Okay, 1,1-difluoroethylene. Okay, so first question is what they've given is it is a non-polar, very important non-polar compound. So here if you see the bond moments are not getting cancelled, this is polar. So this is incorrect. Here also bond moments will not get cancelled. Okay, it's 1 1, sorry. So it will be like this. So here also bond moments are not getting cancelled. This is also a polar compound. So this is also incorrect. Either the correct answer will be B or C. Now, if you remember in the intensity ratio video, I told you for bromine, the ratio of 79 Br is to 81 Br is what? 1 is to 1. And for this, we follow which triangle? Pascal's triangle. Okay, Pascal's triangle. So, if I draw the Pascal's triangle, 1, 1, like this. So, here what will happen? 1 will be M plus ion peak and the isotopic peaks, the number of isotopic peaks is same as the number of halogens or number of halogens or the atoms that is present. Okay, number of halogens is here, halogen is given, so it will be same as the number of halogens. So this ion is present in all the compounds M plus ion. How many halogens are present? 2. So there will be 2 isotopic peaks, M plus 2 and M plus 4. Total there should be ratio of 3 numbers. So the answer for if it was 2 bromine atoms, the answer would be 1 is to 2 is to 1. Okay, the answer would be 1 is to 2 is to 1. Okay, so is the ratio 1 is to 2 is to 1? No. So dibromo is incorrect. A we have eliminated, D we have eliminated. The only correct answer is what? Option C. Okay, we had already seen this, but we will see once more how we get the ratio of for chlorine. Okay, I'll erase all the ink. Okay, so M plus 2, M plus 4. So M plus means I will keep the ratio of both the chlorine as 35. Now what is the important thing that you have to remember? 35 Cl is to 37 Cl is 3 is to 1. So 35 Cl is 3, 37 Cl is 1. Okay, so M plus value, there is only one possible combination, that is I'll keep both the chlorine, I'll take both the chlorines lower value of atomic mass 35. Now M plus 2 means I have to increase the mass by 2 units. Suppose I keep first chlorine same, I'll increase the mass of second chlorine by 2 units. Okay, or other possibilities, first chlorine I will take 37 Cl, second chlorine I can take same. Okay, only these two possibilities, and M plus 4 means both the chlorine atoms I will take 37 Cl. Okay, so 35 plus 2, 35 plus 2, so total M plus 4. Now you take the ratio. How do you find out the ratio? 35 Cl is 3. So 3 into 3. Whenever line is present, you add a ratio. Okay, 35 into 37. So 3 into 1. Then another, it is a probable combination. Whenever different possibility of isotope is there, you write plus sign. Okay, another combination of elements. So you write plus sign. 37 Cl is 1. 35 Cl is 3. Ratio 37 Cl is 1. So 1 into 1. So the ratio is 3 3s are 9, 3 1s are 3, 3 plus 3 6, and 1 into 1 is 1. 9 is to 6 is to 1. So in this way for dichloro compound we get answer is C. A option we had already eliminated because it was a polar compound and it is given it is a non-polar compound. Okay, so the correct answer for this question is option C. Now let us see this question. This is a question based on what? Based on 1D box. Okay, 1D box of quantum chemistry. So first of all, what you must know is what they've asked to calculate is a molecule is given, a conjugated compound is given, assuming the delocalized pi electron system in 1D box. Okay, we have to consider which model? 1D box. Okay, what is given is estimate the wavelength. Wavelength is what we have to calculate. Okay, and what else is given? Carbon carbon single bond length is given, that is 1.54 Armstrong, and carbon carbon double bond length is given, that is 1.35 Armstrong. Okay, so how do you solve such type of questions? For finding out the wavelength, first what we have to do is we have to find out the HOMO and LUMO. Okay, HOMO and LUMO. Highest occupied molecular orbital and lowest unoccupied molecular orbital. So what we are going to see is that energy change is what we are going to see. Okay, we want the HOMO and LUMO. So first of all, let us count the number of pi electrons. How do you calculate the HOMO and LUMO? Count the number of pi electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pi bonds. So double bonds are 11. Okay, here also it will be useful to calculate the value of length. There are how many pi double bonds? 11 double bonds are present. Okay, and how many single bonds are present? That also we will count now, because that is useful to calculate the length. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what I have counted is carbon-carbon single bond. There are 10 carbon-carbon single bonds. I'll tell you why I have counted this. Now total there are 11 double bonds. So total there are how many pi electrons? Okay, one pi bond has 2 electrons. So total pi electrons will be 2 into 11. So that will be 22 pi electrons. So if you see the energy diagram, we will require how many energy levels? 11 energy levels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, 11 and 12. So if I write n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so n is equal to 11. This n is equal to 11 is going to be our HOMO, because we have to fill how many electrons? 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 18, 20 and 22. So total there are 22 electrons that we have filled. So for HOMO n is equal to 11 and lowest unoccupied will be n is equal to 12. Okay. So the higher energy level is what? Higher energy level is n is equal to, HOMO is n is equal to 11, LUMO is n is equal to 12. So higher energy level n2 is equal to 12, n1 is equal to 11. Okay, so why this is important, I will tell you in a moment. So delta each energy changes, we know hc by lambda. And what is the energy for 1D box? N square h square by 8 ml square. Right, so we want wavelength, right? So h and h gets cancelled. So rearrange, okay, cross multiply. What will be the expression for wavelength? Lambda will be 8 ml square c divided by n square into h. Okay, we have cancelled only one h. So one h will remain as it is. So which all values we have with us? 8 is a constant. We know mass of electron. L is missing. We know speed of light. And h, we know Planck's constant. N square. Here it will be delta n square. That will be what? 12 square minus 11 square. Okay. Okay, that we can calculate. 144 minus 11 square is 121. So this will be 23. So now we have delta n square as well. What we don't know is length. Okay, for L value, I have counted this number of single bond and double bond. So which bonds you have to calculate? Only those pi bonds that are involved in conjugation. So you can see the conjugation starts from here, from this carbon that I'm showing in circle, and it ends at this carbon. So the entire conjugation length, you have to count the number of double bond as well as single bond. That is what we have done. Now we have to count the total length of the this conjugated system. That will be the length of our 1D box. L is the length of the 1D box. So total there are how many single bond? 10. So 10 into length is 1.54. plus how many double bonds? 11. 11 into 1.35. So you solve this. This comes out to be 30.25 Armstrong. But do we want Armstrong? No. We want 30.25. 1 Armstrong is 10 raised to minus 10 meters. So this is the length of the box. Now substitute all the values. Okay, lambda is equal to 8 into mass is m is what? Mass of electron. Okay, they are saying pi electron system, right? So it will be mass of electron 10 raised to minus 31 kg into L square. L square is L is 30.25 into 10 raised to minus 10. The square of this and unit is meter. So meter square into c speed of light 3 into 10 raised to 8 meter per second. Okay, divide by delta n square we have calculated, it is 23 into Planck's constant is 6.626 into 10 raised to minus 34 joule second. Now joule, is it useful here? No. For cancelling the unit we want kg meter square second raised to minus 2. This is joule into second raised to 1. Okay, so minus 2 plus 1 will be minus 1. So minus 1. Now we can check the units. Okay, kg gets cancelled. Meter square get cancelled. Second inverse get cancelled. What is remaining is meter. So this you multiply in the scientific calculator. The answer that we will get is 1.3114 into 10 raised to minus 6 meter. Okay, final answer in the question, it is asked in nanometer. So what we will do, we'll shift 3 places to the right. Okay, point will be here, that will be 1311.4 into 10 raised to minus 9 meter. And this is what? 1 nanometer. So the answer is 1311.4 nanometer. Okay, that is the correct answer is between 1200 to 1400. So the correct answer will be what? Option B. Okay, I hope you have understood this solution. How did we do? First we calculated the HOMO and LUMO. Why? Because we had to calculate delta n square. Then we calculated the length of the box by counting the number of pi bonds and the number of carbon-carbon single bond. Then we calculated the total length, converted Armstrong to meter, and then we substituted all the values and we got the value of wavelength. Okay, this rearrangement was also very important. The relation between energy change and the energy of the 1D box. Energy of the particle in the 1D box. Okay, so the next question, this is a molecule, which molecule will have lowest RF value? So what is RF or retardation factor? It is, if you see the formula, it is distance traveled by solute. Distance traveled by solute divided by distance traveled by solvent. Okay, so if you know silica, the TLC plate is made up of what? Stationary phase. Okay, there is one stationary phase. Okay, that is mostly silica. In case of TLC, thin layer chromatography, it is silica. Now silica, if you see the silicon oxygen bond, it is what? It is a polar bond. So what will happen is the polar compounds have affinity towards the stationary phase. Okay, polar compounds have affinity or they like stationary phase. So what will happen once you spot the spot on the TLC plate? Suppose this white one is for a polar compound. So it will travel to some extent and it will stop. Okay, it will have very less distance. The distance traveled will be very less. Okay, whereas if you take any non-polar compound, what will happen? Non-polar compound will have affinity for non-polar mobile phase. Okay, like hexane. Okay, hexane is a non-polar compound, alkane. So since it has affinity for the solvent, so what will happen? It will move along with the solvent. Okay, the solute will travel with that particular component which has likely more, which has similar properties. Okay, so here the property we are comparing is the polarity. Polar compounds will be attracted or more it will have more affinity for stationary phase. Non-polar compounds will have affinity for non-polar compounds like non-polar solvent. So it will travel to a larger distance. Suppose this is yellow is a non-polar compound, it will travel to a larger distance like this. Okay, this is, let's say, solvent front. Okay, maximum distance traveled by the solvent. So in short, what you can say is RF value for a polar compound it is less, for non-polar compound it is more. So you can remember this, that RF value is inversely proportional to polarity. Okay, you remember this, that will be best. So what is the meaning of this? We saw just now, polarity is more, it will not travel much, so RF factor will be lower. Okay, so question is which will have the lowest retention factor? We want the lowest retention factor, so we have to find out the most polar compound. Now among all these compounds you can see here all are CH bonds, which is non-polar. Here also all are CH bonds, so this is also, this is non-polar compound, it will have maximum RF. This will also have higher value of RF. Okay, now between A and C, which is more polar, obviously NH bond is going to be more polar as compared to carbon oxygen bond, because electronegativity difference here in NH bond is more. So C is incorrect. Correct answer will be A. Why? Because this is most polar. Okay, polarity is maximum, RF value will be minimum. So what is the correct answer? Option A, that is this compound. Correct answer is option A. Okay, now this is the last question of this video. Calculate the number of ways of dividing 10 objects into 10 distinguishable objects into 3 groups, 2, 5 and 3. So how do you do this? Okay, number of possible ways, that is nothing but it is called as microstates. Okay, this if you, when we study statistical thermodynamics, we calculate microstates. How, what is the formula for that? Total number of particles divided by the multiplication of the n factorial. Okay, so pi means, always remember, summation means you have to add, pi means you have to multiply. So total there are how many objects? 10 objects. So 10 factorial divided by multiplication of n factorial. We have to group into 3 groups. There are 3 groups. So this will be 2 factorial multiply by 3 factorial multiply by 5 factorial. So what I can do is 10 factorial, how I can write this? 10 into 9 into 8 into 7 into 6 into 5 factorial. Why I have written till 5 factorial? So that I can cancel this 5 factorial and this 5 factorial. Now what is 2 factorial? 2 factorial is 2 into 1. 3 factorial is what? 3 factorial will be 3 into 2 into 1. Okay. So 2 and this I can cancel. 2 5s are 10. Okay. Now there is 3 2s are 6. So 6 and 6 get cancelled. Now the remaining numbers you multiply. So 5 into 9 into 8 into 7. So 5 9s are 45 into 9 8s are 72. Okay, you multiply this, the answer comes out to be 2520. So the correct answer is what? Option D. I hope you have understood all the solutions. Thank you so much.